In this video, we are going to create a classic pass-through platform that is scalable, only allows certain pawns to pass through it, and in this case, we're going to use Paper2D to make it sprite-based. We're going to accomplish this by using a blueprint interface, creating a custom object channel, updating some collision presets, and creating a blueprint actor for our platform. So, without any further ado, let's get started. So first thing we're going to do is set up our inputs as well as our custom object collision channel. So let's go to Edit, Project Settings. In the left-hand side, under Engine, go down until you find Input. Under Action Mappings, we're going to add a new action mapping. We're going to call this Dropdown. And I'm going to assign this to the keyboard letter S because we're using WASD, so S would be down. It's the most logical. That's all we need to do for that. So let's come back over to Engine and go to Collision. Under Object Channels, we're going to click New Object Channel, and I'm going to call this Player Pawn. So if you wanted an enemy that could pass through these platforms as well, you would need to make another channel for that enemy, and then inside what we're doing later, you'll understand where you would need to plug it in for an enemy to be able to pass through. But right now, we're only worried about our player. So we're going to set the default response to overlap so that we don't have to reset all of our presets to include it. And accept. We're going to open our presets, and the only ones we really care about is the block all, so it needs to be set to block, and the block all dynamic, we need to make sure that it is also set to block. The rest of them should be fine, so we can close that out. So we have our collision channel and our input. The next thing we need to bring in is the sprites we're going to use for our platform. So I'm going to go to my Paper2D folder, my Castle Dungeon set. I'm going to go ahead and import that. So this is the Castle Dungeon Pixelart tile set. It's on Game Dev Market, and I'll put a link to it in the description below if you're interested in it. It is not mine. I can't pronounce the guy's name either. So I've extracted the platforms into their own separate sheet. So I'm going to bring them in. Right-click, go to Sprite Actions, Apply Paper2D Texture Settings. Right-click, Sprite Actions, Extract Sprite. I'm going to switch from the auto to grid, and I'm just going to erase sprite from the naming. I know that these are 16 by 16, so I'm going to set the cell width and height to 16. We can zoom in and see that it's going to give me the sprites as I want them. I'm going to extract those. We don't need to do anything to these because we're going to be stripping their collision away within the blueprint, and we're not going to be using their collision at all. They're just a visual representation of where the platform is going to be. So the next thing we're going to do is get started on the blueprint for the platform. So I'm going to go to my blueprints folder, right click, go to blueprint class. I'm going to make an actor. I'm going to call this BP_platforms. And inside of here, I'm going to drag it up here into the corner. We need, first off, we need the box collision we're going to use for colliding with the platform. So I'm going to add a component. I'm just going to type in box collision. I'm going to make it the root. And then we need a sphere collision to determine if our player is in range. When our player is in range, that's when we're going to start evaluating their position in comparison to whether they're above or below it. That way we can save on some performance by reducing what's happening in the event tick because we are going to use event tick. So I'm going to come up to my box. I'm going to come down here to overlap all dynamic and change it to block all and make sure that the player pawn channel is checked to block. Compile and save. We need to check the sphere too, overlap all dynamic, and it's set to overlap our player pawn, so that's good. So the next thing we're going to do is go into our construction script. So every time that we add a sprite, we need to change the box extent. We also need to change the sphere radius to be big enough to encompass the new sprite that's been added. We also need to position the sprite every time we add one and then strip away its collision. So let's start with the box extent. I'm going to drag in this box. I'm going to drag off and say set box extent. I'm going to right click this and split its structure pin. The reason being, we're going to calculate the X every time we add something else. The Y and the Z we can pretty much fill out ourselves. We know that our sprite, the sprite that I'm using, is 16, so we know our Z value up and down is going to be 16. The Y value for my tile map specifically, the separation between layers is 4, so I'm just going to set this to 40. So I could have up to 10 layers and it'll pretty much expand through all of them because this is our depth. And then for the X, we're going to calculate that based on how many sprites we have. So I'm going to make a new variable. I'm going to call this platform length in sprites. And we can't have half a sprite, so this is going to be an integer. And I'm going to make it editable, so you can either check the instance editable or click the I. We're going to drag that in. So this is also going to be able to have a slider range, so you can just click and drag on it, 0 to infinity, and the minimum value that we can have for this if somebody types it in is 0, and then the maximum could be infinity. You could have as big of a platform as your computer could possibly handle. So we're going to drag off of this and make it 1, because if we're at 0, we know there's one platform. Next, we're going to multiply this by 8, because if you add 8 to the box extent, it's going to add it in both directions. So drag off, multiply, int times float, 8. And we're going to hook that up to our x. So next we need to set the sphere. So I'm going to drag in the sphere, drag off of it, type in set sphere radius. Line these up, line that up. So I'm just going to say that our sphere needs to be twice as big as the platform that it's encompassing. So I'm going to drag off of where we have the multiply by 8, and then I'm going to multiply that by 2. So float times float, I'm going to set this to 2, and that way our sphere will be 2 times the size of our platform. And then finally, we're going to have to go through every sprite that we add and then strip its collision away. So we're going to end up needing a variable for that. So I'm just going to go ahead and make it. So over here in the variables, plus, we call this sprite. Sprites with an S because it's going to be an array. We're going to change its variable type to a sprite. And it's not a sprite, it's a sprite component. So paper sprite component. Object reference, because we're going to be adding components to this. It's not going to be standing alone by itself. And it's going to be an array. So we can compile and save. I'm going to drag in our sprites array, get, and for each. So drag off for each loop. For each one of these sprites, we want to take away its collision. So we only do this once, and it's on construction. So drag off of that, set collision enabled. We want no collision. So this is the end result of our construction script. We can hook it up and actually see the boxes and stuff changing. So I'm going to come back to the viewport, switch to right. And if we go down to our length and sprites and change this, you'll see every time we add a new sprite, it will expand outwards. Set it back to 0, and we only have 1. And this kind of looks weird, and it's because I did make a mistake. This box extent needed to be 8, not 16, because it's going to be half the size, because it'll add it both ways. So when I compile and save, you'll see when we put a sprite in here, it'll fit it better now. Okay, so I'm going to move this down, because this is what we're going to end up with. But we're going to start out, we need to populate our sprites, so it's going to be added in. So the first thing we need to do is clear our sprite array. Otherwise, it's just going to continuously add sprites every time we increase or decrease the value. Next, we're going to start our for loop using our platform length in sprites. So for each sprite we have, we need to populate the array as well as add that sprite as a component. So pull in your platform sprite, we're going to drag off of it and type in for loop. And it's actually going to be the last index, not the first. So reconnect that. Line this up. So for each sprite we're going to have starting at 0, we need to add that component, but we need to know if that component is by itself, if it's a centerpiece, a left end, or a right end. So we're going to test for each of those cases. One thing I'm going to do is promote this index value to a local variable. I'm going to call this local underscore index, because ideally it will be the only index we really have to reference. And then we're immediately going to go into a branch, so B and then left click. And this is going to test our platform sprite to see if it's equal to 0. So pull in platform length in sprites, pull off of it equal to 0. If it's 0, then we know we only have one sprite, and that's going to be a singular platform piece. So we'll put the representation in for it specifically. So drag off of this, and we're going to add a paper sprite component. Down here it says relative transform. We're going to right click that and split structure pin, just so we don't have to feed anything in, but it's going to be exactly where we want it at 0, 0 in the middle. So I'm also going to then promote this to another local variable. I'm going to call this local underscore sprite, because we'll be referencing this every time we're populating our array. So this is going to get filled out multiple times. So the next thing we're going to do is drag in our array of sprites, get it, and then we're going to add this new element to it. Even though it's only one, we're still going to add it, because at the end of our construction script, we're going to have a loop that goes through. I think we've already done it. A loop that goes through and takes off the collision. So even if we only have one, it'll still take the collision off. So the next case scenario that we need to test for is if it is the left end, right end, or a centerpiece. So we're going to drag off of the false. So if it's more than one, we got to test and see which part it is. Type in add paper sprite component. We're going to right click and split the structure pin again. I'm going to drag these down further. Also, once this loop is completed, that's when we'll jump to the end. So I'm going to go ahead and hook that up. Now in here, we have to actually make some changes because every time we add a new sprite, it's going to have to be moved to the left or to the right of 0, 0 on our coordinate plane here. So anything going this way will be negative, anything going this way will be positive. So if we had 2 sprites, we would have to move one -8 and move the other one +8, and then they would meet in the middle. Because this is a coordinate plane, it's going to be negatives and positives. When we add a whole bunch of sprites, we have to divide it in 2, and for the first half we got to subtract, and for the second half we have to add. And I'll show you how we're going to do that. It sounds more complicated than it actually is. So I'm going to split this relative transformation location. So split this structure pin, because we're only worried about the x-axis. Okay, and so when we put one of these in to figure out its location, we're going to need our local index. So I'm going to drag in local index and get it. I'm going to control click and drag in our platform sprite and get it too. We need to make this a float, so I'm going to type 2float, and it'll be 2float integer. We're going to add 1 to our local index so that we start counting at 1. And then we're going to add 2 to this one, so +2. And then from there, we are going to subtract. So I'm actually going to 2float this one as well. We're going to subtract from it, float minus float. Before we subtract, we need to divide this in 2. So float divided by float, divide by 2. So the top number is going to get subtracted by this new value on the bottom, and then we're going to multiply that by the size of our sprites. So float times float, and in this case it'll be 16, I believe. And then that will be what is plugged into our x value. So with that done, I'm going to select all this, right click, I'm going to collapse node, I'm going to call this position math, just so it looks a little cleaner. Alright, next thing we need to do, now that we've got the sprite and we know where it's going to be at, we need to set what it looks like. So I'm going to alt drag in local sprite variable. We're going to set it to this new one because we're going to end up adding it to the array. Next, we're going to go through 2 branches to determine the 3 states it could be. So it could be the left end, right end, or a center. We're going to test for the left end first. So if it's the left end, we know if we control click and drag in platform length and sprites, we know that if our local index, so drag that in too, is equal to our length and sprites, then we're at the end and it's a right piece. It'll be at the right end. So in that case, we need to set the sprite, control drag in local sprite, drag off of it, set sprite, and I'm going to promote this to a variable, and I'm going to call this sprite right end, and we're going to make it instance editable so that we can change it when we place it in the world, just in case we have multiple types of platforms that we want to use. I'm going to hook that up to true. I'm going to go ahead and assign this a value, so I'm going to compile. And then over here, I'm going to find my right end and add it. As you can see, that's the right end. And then we're going to add that to our array. So I'm going to pull in the sprite array, get, drag off, add, connect, and we're going to add the local sprite. Straighten this stuff up. Okay, so that'll be our right end. We need to set the sprite up here too. I skipped over that. I wasn't thinking for some reason. So I'm going to just Control-C, Control-V, add this up here. Get rid of that. And this is going to end up being our singular piece. So I'm going to go ahead and select it and then promote to variable. Call this sprite singular. And make it instance editable. Compile. You can see it has an end on both sides. Put this stuff down. Okay, so let's go back down here and test for the rest of the stuff. So I'm going to press B. So now we're going to be looking at if it's the left end. If it's the left end, then we know the local index is set to 0. So just drag in local index equals. If this is 0, then we know we're at the left. Since we're evaluating whether or not it's a singular position, we can evaluate this at 0 down here, and we don't need to worry about it. And we're going to do the same thing. I'm going to select this, Control-C, Control-V. I'm going to do it twice. Because if it isn't at 0 and it's not the rightmost piece, then it's a center piece. So if all three of these branches turn up false, then we know that we're looking at a center piece. So I'm going to promote this to a variable, and I'm going to call this sprite left end. Promote this to a variable. I'm going to call it sprite center. Arrange them. I'm going to compile. Go ahead and set this left end. Go ahead and set the center. And then, after we do that, we need to add those to the array as well, so that at the end of this, we can strip away their collision. And that should be everything we have to do in the construction script. So I'm going to compile and save. If we go over to the viewport and we switch from wireframe to unlit, you can see because our platform length in sprites is 0, so we have the singular piece. And as we expand it, it will add more and more sprites as well as update the collision correctly. So I'm going to pull that back down to 0, compile, save. So let's go over to our event graph. We won't need our event begin play or our event actor begin overlap, but we will be using event tick. We're going to do some things to make it not so costly, but let's get started on that. First thing we want to do is evaluate if our player is in range, so if they are within our sphere, and we also want to know if the player is dropping down, so we need some variables for that. I'm going to hook up the event tick. I'm going to promote this to a variable. I'm going to call this B dropping down, and then I'm going to drag off of this and type in and we want to know if the player's in range, so I'm going to right click over here and duplicate this. I'm going to call this B player in range, and we're going to hook that up here as well. So if both of these are true, we're not going to do anything. If the player is in range and they're dropping down, we're going to handle the dropping down when that event is called. But these are just to keep us from continuously resetting the collision state of our box, which is what we're going to be doing next. So now we need to know if the player is above or below our block. So if one of these is false, then we go on to the next step, which is going to try to figure out where our player is standing. So we need to get our player character. We need to get their location. We only care about the Z value because we only want to know if they're above or below. So I'm going to split the structure pin. We're going to get our location. So type in get actor location. And once again, we only want to know the Z value. So if the player's Z value is less than our actor's Z value, then we know they're below it. However, if they try to jump through the platform, as soon as they reach the center of the platform with the center of the actor, it will turn the collision blocking back on, and it will cause them to shoot upwards in a really jagged motion. So you may have to do some trial and error to get the right value. For me, it's plus 27 for the sprite I'm using, and I got that by dividing my sprite's height in half, and then subtracting 8 or half of the height of the sprite that the platform is made out of. So if they're below, then we need the box to block collision. So I'm going to drag in the box, drag off, set collision response to channel. We're going to set it to our player pawn, the custom channel that we added in, and we want it to ignore. Or, yes, ignore. So if they're below, we want it to ignore, meaning that they can jump up and go through the platform. I'm going to Control-C, Control-V. So if they're above it, then we want it to block them, meaning the only way they can get through is if they activate this dropping down. So I'm going to line these up. I'm going to select all this, right-click, and collapse it to node, and I'm going to call this Z value gate. And I'm going to line these up. So the next thing that we can do right now is go ahead and evaluate our player in range. So I'm going to click the sphere. I'm going to come down to here where it says event begin overlap. I'm going to add that event. I'm going to pull off, and if it is equal to our player character, so get player character, then it will be set to true. So I'm going to press B and make a branch. So if this is true, it will return true. So I'm going to hold in Alt and drag in B player in range. We're going to set it to true. And then we got to do the opposite. So as soon as they stop overlapping, we got to set it to false. So I'm going to click sphere, come down here to component end overlap, and drag it up, drag off other actor, press equal equal, set it to get player character again, make another branch, connect them up, and then Control C, Control V. So if the player ends its overlap, we want to set that to false. So to do anything else, we need our BPI, and then we need our player to be able to call the function from the BPI. So I'm going to compile and save, come back to my test level. I like to put my BPIs in my gameplay or data folder, but I'm going to put it in gameplay. I'm going to right click, go to blueprints, go to blueprint interface. I'm going to call this BPI underscore dropdown. If you already have a BPI that handles interactions, then just update that one instead of making a new one. We only need one function. I'm going to call this player drop down, just so that when we call for the event, it doesn't get confused with everything else that's now named dropdown. Compile and save. We can come back to our BP platforms. Go to class settings. Down here where it says implemented interfaces, press the add and type in BPI. And then we have to compile to get access to that. So now we can right click and type in player drop down. So when the function is called, right here where it says event player drop down, that is going to set our player dropping down to true. So I'm going to alt drag that in. It's going to set it to true. And I'm going to come up here to where we have ignore. I'm going to copy this, Control C, come back down to our event, Control V. So it will ignore collision for our player pawn. It's going to delay for a few seconds to give them time to fall through the platform before toggling the collision back on. And then we're going to set the B is dropping down to false, which means it will then evaluate. It'll go back to evaluating if the player is below the platform, what to do then. I may have made a mistake up here, but we'll find out when we test this. So that's everything we need to do for the platform. I'm going to compile and save. Now we need to look at our character, our player character. So first thing, we need to add into our class defaults, or in our class settings, we need to add that BPI. So BPI drop down. Then we need to come over here, right click, and say input drop down action. When that is pressed, we want to get all actors with interface. We want to get our BPI drop down interface that we just made. We want to, for each of them, so for every one of them in the level, we want to evaluate if that's the one we want to drop down on. We want to get that actor's location, so get actor location, because we only want to get the ones that are close to us. So right click down here, get actor location. We want to get our player's location. We need to know the distance, so type in distance and it'll be this vector. So plug in your vector 1, which will be the platform's location, and vector 2, which will be our location. We want to see if this return value is less than, let's say, 600. So as long as the player is within 600 Unreal units, it will send the message to perform the drop-down action to it. So I'm going to press B to make a branch, connect this up, straighten it. I'm going to select all this, right-click, collapse node. I'm going to call this distance gate. So if they are in range, then we need to drag off of this array element, and we're going to call player dropdown. We're going to send that message to it. So I'm going to select all this. I'm going to hit C. I'm going to call this input action dropdown. And that's it, just so I know I can find it if I'm zoomed out. So the next thing we need to do is come up to our capsule component, scroll down to our collision, and we're going to change our object type from world static to player pawn. And I'm going to compile and save. If we've done everything right, we should be able to drop our platform into the world, scale it up, and it should scale to size. Perfect. I'm going to try to match it on this ledge so that my little enemy there can run across it, and you'll see that he doesn't fall through. So now it should be blocking us, and we should be able to press down and fall through just like that, and the enemy doesn't fall through when we do it. they continue to run back and forth, no problems. And I can jump up through it. I can jump while I'm on it and not fall through. And I don't go through till I press S. And there you have it. If you enjoyed this video or found it helpful, please consider subscribing as well as giving this video a like. If you have any questions or suggestions, hit me up in the comment section down below or contact me through any other medium. Thank you for watching, and I'll see you in the next one.